Right, so on page 272, our goal today is to be able to say, hey, we have a linear function, or hey, we have an exponential function, or we have a quadratic function, okay? We did spend some time a couple chapters ago talking about the difference between linear and exponential. Well, now we are going to look at throwing in the quadratic functions in there also. Okay. Okay. So, if we have a linear function, we've seen this numerous times. The differences are constant, okay? So if we have an XY table, I'll give you time to write down this XY table. Okay, so first of all, we always have to look to make sure that our x's are consistent, okay? Are we going up by the same amount for our x's?
Yes.
Okay, because it does not make sense for us to look at the y patterns if our x isn't consistent, okay? So what do you notice about the y values?
Goes down by 3.
Okay, so here we subtract 3, subtract 3, subtract 3, subtract 3, okay? If we are adding or subtracting the same number over and over from y value to y value, then we know we have a linear function. End of story. Okay. If we have an exponential, okay, then we have a common ratio. Do you remember what that looked like? I'm guessing that's a no. What do you remember? We're going to either be multiplying or dividing by the same number over and over. Okay, so write down this XY table and then we'll talk about it. What do you notice about the y values? Okay, well, first of all, hold on. I'm going to retract my steps here. Our x is consistent.
Yeah.
Okay, they're each just going up by 1. They need to go up by the same amount no matter what. Our x's have to be consistent. But then what do we notice about the y's? From y value to y value, we are multiplying by 2. Okay? If we are multiplying by the same number from each y value to the next, then we have an exponential function. Okay? Now, if we have a quadratic then it says something weird like the second differences are constant. So I'm going to draw an XY table down here. I'm going to have you draw it. And then we're going to talk about what the heck that statement means. Okay, are our x's consistent? Okay, that's good. Now, I can already tell that we are not multiplying by the same number over and over, right? We are not adding or subtracting the same number over and over, okay? Well, that doesn't mean automatically that it's quadratic, but this is what it's going to look like if it's quadratic, okay? From -1 to -2, we would subtract 1. Do you agree? From -2 to -1, we would add 1. How about from -1 to 2? How about from 2 to 7? Okay. So then we look at those numbers. -1 to +1 is up to. 1 to 3 is up to. 3 to 5 is up to. And since all of those are the same, that's how we know it's quadratic. So we have to look at the second differences. What's the pattern adding or subtracting of the y values? And then with those numbers, are we going up or down by the same amount? Kind of weird, but that's how it is. Okay. Okay. So we are going to skip all the way to 2 pages, and I want you to look at, with your table, number 5 and number 6.
Ooh, this one's look at it.
Well, don't just look at it.
There's a whole vertex there. Miss Holman. Don't do that.
Interesting.
Can you please tell me what you mean?
Do we have to do it again?
Nope, it's just no.
So none of them?
None of them.
So is it no solution?
Well, it's just, it doesn't have, yeah, it's just none. Okay, I'm having some people run into some problems with number 6. Okay, first of all, tell me about number 5. What is it?
Linear.
Number 5 is linear because we are down 3 each time, right? Okay. Now, with number 6, is our X column consistent?
Yes.
Okay, I guess I should say row. That's okay. All right, well, here we're down 4, correct?
Yes.
And then down 2, and then up 2, and then up 4. So some of us get really excited, right? But how do we go from -4 to -2?
Adding 2.
What about -2 to 2?
Minus 4. Plus 4.
Are those the same?
No.
Hi.
CC Junior was in your side.
Not today. Or not this class. Okay. Sorry, guys. That was kind of a letdown. All right. So how about you try number 7? So number 7, look at the y values. And number 8, look at the y values. See what you can determine. Ready, set, go. Yeah.
First number is write it down. -2. Number 7 is 0.
And then
X is a -4.
finding the x is
It's plus 3 because it's a quadratic.
like
It's
when
linear.
you use
You share.
because it's from the confusion with someone just
Yeah, plus 9 is plus 3.
Yeah, so this gives us the
Write it
x
down,
of our
babe.
vertex. So like I would write a b right there. Okay.
0.
Okay, so like I told you, hey, let's do this. And over here I said, hey.
No,
I will tell you. Okay, and if you're not sure. Okay. All right, do you have an opinion about number 7?
Linear.
Linear? What's our pattern?
Plus 3.
Plus 3, plus 3, plus 3. Okay, I'll give you a couple, maybe another minute to finish up number 8 if you have not.
Oh, it works. See?
There you go.
I was just wondering because you can add, subtract.
All right. What you think? All right, I'm hearing quadratic. Let's check. All right, from -9 to 0 would be up 9, right? And then we go up 3, and then down 3, and then down 9, right? So if we look at those, 9 to 3 is down 6, 3 to -3 is down 6, and -3 to -9 is down 6. So we have quadratic. Are you okay with that?
Yes.